TechCast. You know, topic for today is next big waves of cloud computing and trends for the future. You know, guys, just make sure you give me a confirmation on the chat box where on which whether you can hear me or not, if I'm loud and clear to you. Let me just type it on the chat box for you. Am I audible? You can go ahead and reply yes or no. Meanwhile, let me just go ahead and check the audio with Sujeet as well. Hey Sujeet, welcome to the TechCast and thank you so much for joining. Are you able to hear me? Can you just give me a confirmation on that?
Yeah. Hi, Ravi. I'm able to hear you properly,
Thank
loud
you.
and clear. Thanks.
Thank you. Thanks a lot. Thanks a lot. So, guys, today, we all know that cloud computing is being used extensively by many organizations and businesses, right? We all know that right from the U.S. Army to the local restaurants, everybody is trying to use it, to lower your cost and also to improve the business efficiency, So, in fact, that actually brings so many questions in my mind, and one of them is that what does it actually mean for, IT professionals aspiring to build a career in this domain and and this is a very big question, right? Which have so many different factors associated with it, you know so and for that, we have Sujit, Sujit Saxena with us, who is an expert in cloud computing, a friend of mine, and as well as the chief manager of IT at Siemens, right? So he's a great personality, a great person at heart, and a good friend of mine. So Sujit, basically I get so many questions like this, that how is cloud computing impacting the business today, as well as the people who have, a lot of, ideas and a lot of, goals which they want to, get in IT field, and how can cloud computing, can help them in do that. So, without further ado, guys, let me just go ahead and ask the man of the hour, Sujit Saxena, to go ahead and share his knowledge so that you can benefit out of it. So, Sujit, you know, you can please take it away from me, and I'll be more than happy to, guys, I would really appreciate if you can note down the note down the points that he's saying, because it's going to be really important to, build your career in cloud computing. So over to you, Sujit.
Thanks, Ravi. Thanks for the nice introduction and nice lines about myself. And I share really your concern. What about you mentioned about the cloud computing? There are a lot of questions which many of newcomers, even the experienced professionals, think about that, and they try to think about what is it that cloud computing is, what is the hype about, and how is it really affecting the organizations, how it developed, and what are the future trends, and basically what is in it for me. So that is something which um, normally a person connected with IT thinks of. So what I'm now sharing is starting to share my first slide, which is there. I hope you are all able to see that. Ravi, if you can just confirm that you are able to see the slide.
Oh, well, yes, indeed, I can see digital economy.
Okay, right. Thanks. Good morning, good afternoon, and good evening to all the persons who have joined. And thanks for joining this webinar. I'll be sharing my view and also views which I have collected from different forums and different technological experts from the internet, and based on my experience, the digital economy. The title is Digital Economy. Why? Because primarily we are all moving at a rapid pace towards the digital economy. And I will be giving during my presentation bits and pieces of the information how at what pace we are moving. And I chose this picture because this picture really gives an idea how a kind of cloud is affecting all kinds of communication channels and interfacing channels which we have today. So it just starts from mail to computers to networks to globalization, digitalization, mobile. Everywhere you are somewhere in the background connected with the cloud. And if I take an example in a very simple way, most of us would be using some kind of email, public email, Gmail or Hotmail or Outlook or whatever. So this is a very simple example of the cloud service which is now there. Okay, moving to the next. This is the agenda which we will be talking, which I will be talking about. So how is cloud computing's beginning, development, and present state? What are the pros and cons in a very broad term? We'll not go into much details of that. What are the possible job roles in cloud computing, and what are the future trends? So this is the broad agenda which I'll be taking up. Like I said in the first slide, I'll be giving you bits and pieces of the data, how we are moving towards the digital economy. So just to sample a few numbers you see here, so we have 120 hours of videos are uploaded to YouTube every minute, every day, and there are more than 200 million email are exchanged every minute. And the last one is really surprising and gives you the rapidness of the digitalization which is going on. A server gets activated every 10 seconds to support new smartphones. So this is something which gives you an idea, a mind-boggling idea about this, how things are moving at a fast pace, and this is increasing every day. So definition. So the first use of the terms cloud computing was there somewhere in August 9, 2006, and it was coined by Google CEO Eric Schmidt with an broad introduction that this is a data service which is provided by servers somewhere in the cloud, and this is they call it as a cloud computing. And University of California, Berkeley defines cloud computing as providing the illusion of infinite computing resources to end users on demand. And this means eliminating the upfront investment. So there's no upfront investment and the services are available to the users. And going forward, we'll see also how NIST is defining these terms in different categories. This is a bit of data overloaded slide, but what it primarily gives you a timeline with the events which have happened. I'm not sure if it is visible to the text to all, but the first one is normally the mainframe, which is starting around somewhere around 1950. And this is kind of basis for the overall computing environment and also in a way for the cloud computing. Then the next one is in around 1969 with ARPANET coming in and forming the basis for Internet. At around the same time, 1 year later, 1970, IBM released an OS called VM. So this is multiple virtual machines on time sharing. So you see everything, the concepts are coming in and the concepts are already really there building in. Then the PCs came in, which formed the real basis again for reaching everything to the individual at a level. The next step was telecommunication companies starting VPNs, which again formed, helped cloud computing basis with the segregation of networks possible in 1990s sometime. Then in 1996, this is a cloud computing term coined by Ramnath Chalapa, and Compaq used the term in more details with the modern context in 1996, but unfortunately they could not really get it on cash it on. Next was Salesforce.com. They started delivering applications over the web in around 1999. And then finally, Amazon came with their Amazon Web Services in 2002. So, from 1999 onwards, the new era of the cloud computing is started. The next one is 2006. There we have Elastic Cloud Computing Cloud from Amazon, which again from Amazon, and they allowed small companies. It allowed small companies to get computing infrastructure out of the internet itself. And then Google, Microsoft, and other players came in with their own apps in 2009. So you see, this is all coming on in a very gradual development, and all the technological things which evolved over a period of time have contributed to the development of the cloud computing. Okay, now what does it look like today? If you see just Google and term cloud computing, you see these kind of ads which is there, and which says like Amazon is saying 40 plus products, 12 months, $0 cost to you, sign up for a free AWS account today. So, and all kind of certification compliant also. So HIPAA, so that's kind of healthcare industry compliant, which is already there. You have secure document sharing. Similarly, IBM is also offering, and there will be so many ads coming in. So the idea to share this slide is that how it has become a kind of utility computing, which was the original idea from the ARPANET person, that some days this computing will be kind of utility computing, and everybody like electricity would be able to use it. Okay, now coming to the foundational elements. What are the basic foundational elements? So this is more or less a compilation of some of the elements which we have seen earlier in my earlier slide. There we see how it evolved. So, but the basic elements on the modern cloud system, which is making it possible, is virtual private network. Like I said about segregating the network, so you can really have each customer with its own pipeline going to the cloud. Internet bandwidth. So increase of internet bandwidth over a period of time to each individual consumer and organizations has really paved way for the possibility of really getting it to each user. Then there is increase of computing power, so each individual computers are really possible to get so much power which mainframe of the yesteryears cannot imagine, and even the data centers of the cloud providers are carrying so much power that they are able to serve thousands and millions of customers every day. Grid computing is a very excellent example, because this really gave an idea about how you can connect different computers and really get the compute done out of a network of the computers. So this was kind of combining different computers' computing power and getting the result out of that. Virtualization, we saw VM, which was created by IBM earlier on a time sharing basis. But this is virtualization of the virtual machines creation, which was done. Service-oriented architecture, so targeting all the architecture into a kind of service mode instead of a product mode. So everything is available to you as a service. Like, for example, even for a plane nowadays, if a company goes to buy a plane, then they ask about the payment in terms of the flying hours. So not in terms of buying the planes, but in terms of payment using in terms of flying hours. Utility computing, I mentioned about that already. So utility computing is there. Browser-based applications, Salesforce started that already. Open source, there are so many things everybody is able to develop and put it on. And this is basic characteristics of the cloud computing. Now, this is a definition based on NIST, National Institute of Standards and Technologies from US, and it defines primarily in 5 characteristics for a cloud service. So it should be on-demand self-service. That means the service is available on customer demand and it is customizable by the customer up to an extent. And we'll see that in different models also. Available over internet. So services are delivered over internet or intranet. And when I say intranet, then because there is a model which is private cloud as well. And for that, normally this is under different kind of VPNs or tunneling networks. This is more or less an intranet. Resources are pooled, so all the cloud providers, they are putting all their resources as a pooled, and they are providing with multiple customers with logical separation and isolation of the data. And it is quick and easy to scale up and down. So you can really, the customer can really ask demand for scaling up or scaling down depending on their business requirements and how they want to see it in the development. So over a period of time, they can do that. Service metering, it is possible for a cloud provider then to measure the service and also offer a pay-per-use kind of model. So as soon as the customer is going or stopping a service, they are not paying for that. So it's not that you bought a product and then you have to maintain it till you have it or you have to sell that. But in this case, it is a service, like for service-oriented architecture. So service is there, you're utilizing the service, until the time you're utilizing, you're paying for that. Okay, moving to the next. Now coming to the deployment models of the cloud computing. So like I said about a private cloud, this refers to a model of cloud computing where the local IT provider or the local IT organization within the company is creating their own private IT infrastructure for a dedicated use of the organization. And this is normally managed by internal resources, and this is not accessible to outside company. Public is the standard cloud computing model, which is a service provider makes resources available like virtual machines or applications or storage, and this is available to general public over the internet, and they can utilize it. And this is normally based on the pay-per-use model. Some of the companies, like we saw in the ad, there are some offerings as free also to some services. Then there is a community cloud, which is more or less cloud service model created by organizations for the purpose of their own, and they can create a joint collaborative model. For example, Salesforce, they can create a user community and they can host it on their own cloud, and then all the users are coming and sharing their experiences on that. Hybrid cloud is a cloud computing environment which is a mix of private and public cloud. So when the organizations see that they have they need to secure some things and they can offer some things on the public, so they can distribute it on private and public, and this combination is hybrid. So in the next slide, we will see how these deployment models are interconnected. So you see there is this organization 1, which is private cloud. It has its own private cloud. Then there is organization 2, organization 3, and they have created together a community cloud which is serving these organizations. And there is a public cloud also from which organization 1 is taking services, but this is also accessible to all the public cloud, all the public and with data isolation, of course. And hybrid cloud is depicted in general because it has both the public and private cloud. So this is how they are kind of interconnected. Cloud service models. So there are these three service models: IaaS, that is infrastructure as a service; PaaS, which is platform as a service; SaaS, which is software as a service. And the target groups are for SaaS as end users, for PaaS it is application developers, for IaaS it is infrastructure and network architects, and the kind of services provided is these service networks, OS and application stack, servers, and package softwares. Now this is interesting thing, that which service model and what are the enablers for that service model, which are there with the examples. So infrastructure as a service has AWS, Amazon Web Services, Azure, Google Compute Engine, Zscaler, which is very interesting example because it provides internet over the cloud services. Then the virtualization, server virtualization, VPN connections, and data encryption are the enablers which are making this kind of service deployment model possible. MaaS, which is metal as a service, is very interesting because this allows you to have a physical server configuration also available over cloud, and that's a very specific service available. Platform as a service is Salesforce, Google App Engine, Roku, and this enablers making this possible is application desktop virtualization, VDI, automated provisioning. Software as a service is Evernote, it's well known, Office 365, Facebook, Gmail, and the enablers which are making this possible is service-oriented architecture, enterprise service bus, data distribution services. Another interesting thing on the service models is who is managing which layer in different service models. So infrastructure as a service, the user is managing application, data, middleware, operating system, and virtualization. So there is some overlap because of different kind of accessibilities. So managed by cloud provider, they are managing servers, networking, storage, OS, and virtualization. Platform as a service is application and data managed by user, and rest, server, OS, virtualization, middleware, etc. are managed by cloud provider. Software as a service, it is only data which is managed by user. Rest all aspects are normally managed from the cloud provider. Now some facts, some figures which are there. So if you look closely, these are the cloud initiatives which were surveyed from Right Scale. They put a report together in 2017, and there are some interesting things which see, like implementing a cloud first strategy. So there are 40% respondents which are going for cloud first. So that means they are not going to put anything on investment. They will straight away move to whatever request or demand business is there to the cloud first. Then expanding use of containers, and that's also very interesting because containers are really emerging technologies, and these are we will talk about this in a few slides later. And enabling IT to broker multiple cloud services. So this is also one of the interesting things, because if you already have different cloud services, then how to handle them and how to interface them. This is one of the big challenge. And if you see the last one, expanding private cloud, and that's having the least priority because nobody is really interested now to expand their own private cloud realizing that this is only going to give more investment and more manageability costs. Then we come to the next slide on what is the enterprise preferring for, and the preference is for multi-cloud. And the reason is very simple, that nobody really wants to be locked with one provider. So there has to be different kind of services with different kind of expertise, expert provider available. So if you are going to a different provider, then there is a different expertise which is available, and you can directly go to that provider. Now, how private cloud adoption has happened in from 2016 to 2017, and you will see here also the trend that private cloud adoption has either marginally decreased or not changed at all. So only in very few cases this has increased. So this is giving an indication that organizations and companies, they are really looking at for moving or not increasing their private cloud adoptions. Public cloud adoptions, this is giving an idea at what rate this already the companies are running the public clouds. And like for you see Amazon Web Services, 68% are already on the running app, and even 7% are already planning to use. And these three, Amazon, Azure, that is Microsoft, and Google, they are the major players in the market for the public cloud adoptions. There is, however, emerging ones also coming up like Alibaba. They are also kind of starting up to gain. Then we have a look at enterprise public cloud adoption. And this, you see, this is quite different from the private cloud one. So you see, this is public cloud is everybody's increasing towards that, even from Amazon adoption from 59% to 68%, and Azure is 43 from 43 to 58%. So this is even the major players, they are increasing. The organizations are going more and more out for the adoption of the public cloud. Like I said earlier, some more figures. So Cisco analysis indicated that aggregate amount of the data stored in the data centers would be about 370 exabytes, and while worldwide storage capacity would reach 600 exabytes. And these will be developed, these numbers will be developed on an aggregated storage up to 1.1 zettabyte. And even further, the global traffic in 2019 is expected to hit about 2 zettabyte. Now, just to give an idea about, I know we are all learned men about different kind of bytes. So 1 zettabyte is 1024 exabyte, and 1 exabyte is 1024 petabyte, and 1 petabyte is 1024 terabyte. So this is more than 1 billion we are talking about terabytes. And we'll see that about 15% of this would be residing completely on the cloud. We'll see that from the user data. Now we come to the pros of the cloud computing. And as you see, the first one is cost. So cost is there, and CFOs would, from my point of view, CFOs would really love it because you don't have to invest upfront, you don't have any depreciation, you don't have anything to as a asset or liability to be shown in the book, but you have all the kind of resources available which you are looking for. So, and this is the kind of operational cost which is coming, and the company can scale up or down. Then this is pay-per-use model, so there can be difference in operational costs in terms that, okay, you can decide that the company is paying only for a lump sum, maybe every quarter or every 6 months, and even pay-per-use can be that you decide with the, say, Microsoft or some company that Office 365 license measurement is every month, and whatever is measured every month, that is paid. So this is kind of pay-per-use model which is there, or maybe even activated licenses paid and deactivated licenses are not paid. So this is kind of pay-per-use model and the flexibility which is there, which is coming in terms of cost. Scalability, you can have storage. You don't need to really consider the storage part. With the Exchange Online connection, you straight away, if you're going for an Exchange Online connection with Microsoft, normally you get, I think, 25 gigabytes of storage already on the cloud. Same goes with any kind of storage infrastructure like OneDrive, Google Drive, or Dropbox. You get the storage immediately in terms of gigabytes. So, and you don't have to really put any kind of hardware in that. You can get virtual machines created. You can get virtual machines created of different configurations, which are available to you. Collaboration. So that is a very interesting thing because it enables the collaboration across. You just need an internet connection and, of course, a secure internet connection. Then you can just go ahead and create or get Google Cloud services or Microsoft Cloud services, and your users are already connected over the cloud, and they can start sharing the documents. I mean, very simple example, like in the families also, we are sharing the photo albums and different kind of things. So this is, which is the idea about the collaboration, which is already there. Manageability. So manageability is in terms of IT team and IT infrastructure. So you only have to manage the cloud part of it. So basically interfacing with the supplier, how things are moving, the resource calculations, maybe capacity sometimes, but nothing on terms of hardware or putting into hardware, ordering the hardware, installing it. Device independence. So you can access the data on most of the available devices, including mobile, tablet, iPad, computers, laptop. If it is normally seen is if you have an app or it is a browser compatible app, you can really get the data available to you. Even applications like SAP and everything, they provide the data available on mobile. Next is mobility and location independence. So you have that wherever you are sitting, you can get the access to your data. You don't need to really be physically bound to a place where you can access the data. And that is a huge advantage for the mobile workforce of the today. Data isolation from the local storage. So the data from, you are not storing data on the local storage. So data is really isolated from all the local problems which could be there on the machine. It is normally safe if you are already directly connected with the cloud. This slide is giving an idea about how the measurable impact on the business cloud is putting. So there is First one is average improvement in time to market. So because it takes less time to prepare the solutions and less time to prepare the infrastructure, then overall time taken to get things to the market is less. You can quickly access to a network, quickly access to the cloud service provider, and then start taking the time and putting online marketing. So, like for example, this one is also a very good example. The whole presentation was already advertised on the LinkedIn, and this was in no time marketed. Average increase in company growth. So with the fast deployments, this is feasible to increase the efficiency and in terms the growth. Next is average reduction in the operational costs. So there's nothing on premise which you need to maintain, no maintenance on that. So there's no maintenance cost because we are going for pay-per-use scale-up models, and there are less resources to maintain. So overall, these kind of regular maintenance part is getting reduced. And where the company needs to focus in terms of time to market, company growth, orders, process efficiency, there they are able to focus. Coming to the cons, so I would not say these are really cons, but these are more or less a concern which, while deploying a cloud solution or while running a cloud solution, must be considered, taken care, so that the cloud adoption or the running of the cloud service is uh, really run in a secure and a proper way, and the company gets the whole benefit of the running the cloud. So internet bandwidth for connectivity. I mean, if you are planning a cloud, then you need to plan sufficient capacity for the internet bandwidth and vendor lock-in. So you really need to read between the lines for service level agreements with vendors so that you don't find really locked in. So maybe like, for example, if you have stored the data, but you don't read the terms for backup and restore. So if your user is accidentally deleting a file on a cloud, then how do you restore? So those kind of aspects. Control and flexibility. So really need, this is also depending on how you want to control and the flexibility on the terms. Then interfacing from the two service different cloud providers. So if you have dealing with two different cloud providers, and this is what we saw a challenge which is there, which they want to really gear their IT team in the right scale survey, that how to interface with two different cloud providers and getting the services from them. Data security, that is again coming back with the SLA and the kind of offerings. Some of the bigger providers, they are giving good security, but maybe smaller providers are not really geared up for that, and that really need to be looked into. And what kind of checkpoints they are maintaining, what kind of practices, best practices, or information security hygiene they are maintaining. So these kind of things, they are advertising already, but that needs to be really looked into. Data privacy. This is GDPR, and this is the new thing which has come, Global Data Protection Regulations. So that is something which really needs to be taken care by all the cloud providers. And anyway, this is an organization which is affected at the end. Data recovery also, I talked about that. Okay, if you are looking into the SLA, how the data recovery can be done, or if you are closing the term, then how you will get the data back. Okay, I'm coming to a different section now. I will hold and have a look if there are some questions coming in. And I see some of the questions. Uh, what exactly makes serverless different from any cloud-based service? Okay, this I think I will be addressing anyway in few slides later. Which certification is better? Okay, this is also, but anyway, let me take that. In career growth, Salesforce platform developer or service cloud consultant. Um, Primarily, this depends on first how the person is really looking at his own career graph. If they were looking themselves as a software developer or just a cloud, just a consultant. And based on my experience, normally a functional consultant are getting a higher pay up. So this is uh, in terms of pay up, I would say certification is better, but from the satisfaction point of view, it purely depends on the person how they want to really go for it. Okay. A very interesting one. How can a normal business transition to the cloud successfully? Um, this is a kind of phased decision you need to take. If you are a startup or if you're starting a company, this is quite easy. You can straight away go for the cloud-based thing. And if you're a small company, then also it's a bit easy. But if you are from small to mid-size company, then you really need to take up a phased approach and you need to think what you want to host on the cloud and what you want to really keep with you as a kind of efficiency and improvement, or maybe which you think that this you don't really want to share anywhere else. So primarily it is the customer facing things which you normally look at putting in first on the cloud part and on the public cloud really. So when you say transition to the cloud, so I'm assuming that you're saying transition to the public cloud, and that's what I'm trying to put in. It could be a private cloud as well. You can create your own private cloud, and depending on how much you are willing to spend, you can do a hybrid of that as well. Okay, now coming back to the slides. Options for the job role. Hmm. Now there can be different ways where you can have job roles. I'm primarily focusing only on the cloud. However, there can be much more uh, job roles which are created just because of the cloud storage and other kind of services, allied services which are coming because of the cloud part. So there can be technology-based roles and there can be product or company-based roles. So technology-based can be then you're especially focusing on specific technologies and going for that, like container as a service, function as a service, or cloud itself as overall you're doing that. And product and company based is like you're especially targeting towards a product from the company. For example, Azure Container Services. So now you are going for Azure Container Services, especially for that, or for that matter, maybe Docker, which is there. So you're completely going for Docker and doing it. So this is in general how it can be. And when we look at the roles primarily, there can be very broadly three kind of things. One is cloud architect, which is like a solution architect, and this is the person who's really looking at the strategy of the enterprise from the cloud computing perspective, how to plan, what to get in cloud, how to get a structured delivery models, and this will involve the design, implementation, defining the service levels, how to migrate the components from one solution to the other solution. So all these kind of things cloud architect will be looking at. Cloud engineer is primarily on the implementation and management of the delivery models. So it can be any of these delivery models, and cloud engineer is looking at that. And normally, sometimes it is also referred as operations engineer or systems engineer. Then there is software developer. So they are really there as a developer with back-end, front-end, all kind of web application development, data and application integration. This is there, but the focus is primarily on towards a specific cloud solution and not on in general for the software. So this is on the job role. I'll just share a bit of data. So if you see 121% growth rate in job posting between these 4 years, that included the term cloud computing. So you see that the kind of growth it is there in terms of cloud computing, which is now gaining really momentum on a very high level. And different kind of skills looked for in a cloud engineer. So I think this will giving you a perspective already which product is really being looked into by the providers for cloud engineers. And that will really give some of the questions answered already. So like somebody is asking, should I go for Azure or GCP? So you can have a look at this thing and really look at which is there from the market perspective and the employer's perspective, and then you can decide yourself. Now, 2 days back, I just saw in Times of India itself that companies facing talent crunch in cloud data. And if you closely look, cloud architect is the first name which is mentioned there. And this is a real skill which is looked after right now. So cloud architect, and this is coming in even before data scientist, the storage systems and management specialist, and blah blah blah. So this is something which is really being missed by the industry, and they are really looking for. So for example, in this article only, it was mentioned that for every 10 requirements, there are only 2 available cloud architects. So this is the kind of gap which is existing. So the persons who are really looking at maybe cloud engineer, they can also look for cloud architects. Okay, now coming to some of the future trends for the cloud computing, and that would be really interesting. Looking at the time, I will try to be faster. So Deloitte, in one of their reports, said by 2020, what will cloud computing be driving to? There will be a market worth of $241 billion. And that, just to give an idea, this is twice the amount of China spent on the arms in 2011. So the source is ciosystem.com. And this will help cut data center energy usage by 38%, which is very good because then we are going towards more greener part of it. And will host 15% of data availability. This is what 15% I mentioned when I was talking about Cisco figures and in my previous slide, one of the slides. And then cloud computing is also enabling mobility. So if your data is not bound to a data center or hard piece of hardware in some location, then you are really mobile and you can really access the data from anywhere else, anywhere on your device. Analytics. So a huge amount of data collection which the companies which are doing over the marketing or maybe like search engines. So these is the Twitters and all these Facebooks, all that kind of analytics is possible because of the cloud data collection. Mass collaboration again. So like I gave an earlier example, how different companies can collaborate at a level where they can just start with the cloud and they can get the data exchange. And a very good example is Skype for Business. You can immediately get into video and dial connections. Even WebEx, for example, is a good one which we are using right now to connect, and we are really enjoying that platform collaboration. Then huge data set available. So if you really want to see some trends, some kind of things which are there, so you have data available in the cloud, which you can really analyze and get the some kind of trend or problem solving things done out of that data. Cloud-based identity services. So this is something which is there, and we have been utilizing these without realizing. Like if you open your phone and your phone says authorize connections using Facebook, using Google ID. So this is already cloud-based identity service. So one of the service provider is certifying your ID to the other service provider that, okay, yes, this is a known user. So this is kind of cloud-based identity service, which is already available. And there is also at a higher level, it is certificate-based authentication also possible using public key infrastructure. So you can have a soft PKI key for yourself generated, and then this can be used to authenticate you. So this is like organizations like DigiCert, they are providing this kind of services, which is, and there are consortium which are allowing different organizations who are member of that consortium to authorize to each other. So this is turning towards completely collaborative model. Next, I'll jump to the creating specific building blocks. So single function. So this is the future architecture which is coming up, which is in the development, service-oriented architecture, container-based services. So single function meaning they are function is the smallest unit which is available to the user based on the triggers or alerts, and this is completely provided by the cloud provider. This helps some kind of batch processing, so you can really define alerts and triggers and a chain of workflows to get into kind of serverless computing. And I think somebody asked me about the serverless computing, so this is where we are going into. And serverless is you can have everything provided from the cloud provider to you, and you just need to define the alerts and triggers to really get into the services. And even this can be used for IoT, Internet of the Things services, or Internet of Everything, IoE, and this is charged per execution time. So you're really saving, it's only the execution time. So for example, the trigger happens, it is executed, and this is measured and charges based on that execution time. Then microservice is closely linked to the function because you can have a relay or workflow of functions made, which can be a kind of complete service itself, and they are independently working with each other. You can define multiple microservices using that. Container, so you can have Azure container services as an example, and these are the complete environment. So this is a bit higher, a bit above virtual machines, and giving you even the OS and application level segregation. so that you have the full container and then you can define your own application on top and run on it. So there is machine learning. This is kind of my favorite because this is giving open platform as a service like MindSphere from Siemens, which is there as a platform, a cloud platform for IoT. And like IoT is predicted to be 50.1 billion devices by 2020. So this is important or really critical to have a kind of operating system which is able to provide the connectivity and the platform-based services to such kind of trend. And this can then help even for the fleet managers, for different kind of factory-based automations and all kind of things which you can imagine in kind of manufacturing or mobility scenarios. So this gives an example, a kind of movement, how things have moved from 2000 to 2015, and this is going further. And you see data centers, infrastructure as a service, platform as a service, containers, and then the serverless, so which is function as a service. Okay. This gives you a kind of comparative idea how things are different in case of different models. So infrastructure as a service, you see all these are there. And from the previous model, there is a layer above added as function on all four. And you also see the containers also added here, which is put as optional and it can be used or they can be used or they cannot be. So this is already could be possible. It also gives you an idea what is user management possible, what can be scaled, and what is provider management. So you see function as a service, everything is provider management. The scalability on the function is with the user. So you can only work on the function side. You only focus on what is your critical thing from the business perspective you want to get done. This gives an idea about containerization versus virtualization. So like I was mentioning how it is different. So this is giving an idea that virtual machine is having its own virtual OS and app and bins, libraries, everything like that. But here you can have a defined container, and in that OS you can have one app, two app, three app. And similarly on the different container, you can have maybe OS 2 or maybe similarly OS 1. And this is an engine which is running on top. Is machine learning. I've just added 2 slides for machine learning and AI, just giving an interface how things are working. So machine learning in general is an input of data, and then you have them based on relationship, different patterns, dependencies, algorithms, the kind of output which is coming out, and how cloud is helping. Because if you see the function part, so function is completely working or giving you this kind of structure where everything is provided from the cloud provider and you are just into identifying the patterns and getting an output out of that. This is the data science, the artificial intelligence, how they are linked. So what cloud is really able to give here is the support for the big data. You can have really big data stored on the cloud, and based on different kind of new models which are coming like containers or function as a service or even microservice, you can define things on this big data and you can work on getting data mining or maybe deep learning or natural language processing. So you can really get deeper into that. think. Okay, I think we come to the end. Um, we have 1 minute, just 1 minute now. Let me quickly take. Ravi, what do you say? We can take a question.
Yeah, in fact, I have some questions. So basically, one of our learner who is from, whose name is Dominic Johnson, he's attending this thing from YouTube, and he asked that he was thinking of learning Apex but don't know any language, and that's how cloud computing and how you can, he says how can you help him to understand that is it how can he's go from to should he go from for Apex or cloud and how are both interrelated?
That's a good question. I'm just kind of thinking because this is more or less Salesforce kind of interface which you can get with Apex, and if you're really looking for a development career, then Apex could be a good choice because then you can really work on all kind of Salesforce infrastructure or maybe development on Salesforce on top of that. So, and you can be part of the community. This is interesting because Salesforce has been the premier on web-based applications, uh, and I would suggest that you can really look into that for an Apex
Mhm.
kind of thing. But I'm not sure what he means exactly by the language because Apex itself is a developer platform completely. So
Mhm.
yeah,
Yeah, in fact,
so this is
even that would be, that is it's a basically a personal choice on which there are like two different directions. So it's a basically also for a personal choice and interest as well. That's what I believe. Yeah.
yeah, exactly. This is what I also earlier mentioned that how the person looks at his own or her own career choice, they can look in that
Mhm.
direction. This is correct.
Yeah, we have one more question from a person whose name is Ravi. It's my name as well. Well, yeah, Ravi says, can a non-technical guy start cloud computing and cope up with the current technology, or what are the basic steps or basic knowledge that he should have?
Very interesting question, Ravi. And this a non-technical guy, I think at a very abstract level, the person can go into kind of infrastructure setup itself to really get himself or herself acquainted with what is basic at the cloud computing. And I would not discourage, but even today I have to learn a lot. So this is something which is quite evolving every day, and we really need to learn every day. So I would say if you have a learner's question with you, then there is no doubt of going into cloud computing or maybe for that matter any technological thing.
Mhm.
It's only
Yeah.
a knack of learning which you need. That's it.
Yeah, even from the non-technical, one more question comes into my mind. While for a person who is a businessman and he has a group of people, technical people, right? So how can a business can transition into something a very highly profitable business with the help of cloud? Can you just put some light on that as well?
I think the businessman really need to focus on the areas where his costs are going. Being worked for different CFOs and business persons, I know that you need to really focus on first identifying where the costs are. And then based on those aspects, you can really work or he can ask his team to work on kind of optimizing those costs or maybe changing the model of that platform completely. So giving an example, maybe for example, if you are using say, some kind of homegrown software they're using, and they are spending a lot on development and maintenance of that software, that would for sure show as a big kind of cost already in that. And that he can really save by changing that to the cloud model and going for a provider who is providing that service on pay-per-use model. So then it can be in the beginning, it can be a bit difficult. It will look a bit difficult, but as soon as 3 or 4 months or some usual period passes, then they will start realizing the benefits, both in terms of all the cloud benefits and as well as the costing part.
Yeah, that actually, helps the startups as well to, manage that how much they have the budget to invest in cloud computing,
Yeah.
and with the with also keeping in mind, provided that they have a good strength and of technical people who can do it at a lower cost and in an easy way as well. Yeah.
That's the best part, Ravi, with the cloud computing, because you don't need upfront investment on that. You can really talk to the provider and say, I want to start this much in the beginning. And then you can negotiate on top how you want to grow the things in that. So
Yeah.
that's the best part.
Mm-hmm. Yeah, and yeah, okay. Now I've got a question that is favorite or likely to be everyone's favorite. That what is the highest growth rate in terms of salaries when it comes to cloud computing?
Yeah, this is, I mean, uh, nobody's salary is enough. Um, but very frankly, I am not don't have ready often data for the salary change or salary growth rate. But what I have is that the cloud architects, they're really sought after at the moment, and the companies are willing to pay them what they want,
Right.
and that gives an idea of what you can really look towards to.
Yeah, and we all know that the not every knowledge never go waste. Now, a knowledge will always help you. So, cloud, even if you know cloud computing, and you don't know anything else, it is a add-on. If you know anything else, some you have basic technical knowledge, and you also know cloud computing. That's another feather in your hat, right?
Yeah, yeah, correct.
Yeah. So I guess that's all with the questions. I don't have much questions over here from the learner. So thank you so much, Sujit. It was a great session. And yes, we did learn a lot, and we do get, I hope, Ravi, Brahma, Vaibhav, and Dominic. I hope you have your questions were really nicely answered, and this will help you in growing your career in cloud computing. So, as a last note, final note, I would really like to thank Sujit for coming up and giving the best knowledge in the market for cloud and how can we grow our knowledge in cloud computing and also business in cloud computing. So thank you so much, Sujit. It was a great session.
Thank you, Ravi. Thank you. It's an honor. It's a pleasure. Thank you.
Same here.